Today we are going to discuss about the statistical derivation of Langmuir adsorption isotherm. For a gas molecule on adsorption, the free gas molecule, the total energy will be E trans plus E rotational plus E vibrational. And this can be reduced to E trans plus E internal. Here E internal represents the energy due to internal movements, that is by rotation, vibration or electronic transition. So for a stationary molecule there will not be any translational movement, so that E total will be reduced to E internal only. A molecule get adsorbed on a adsorbent. At equilibrium, we know that the chemical potential at equilibrium, the chemical potential in the two phases become equal. That is, the chemical potential in the gaseous phase will be equal to that in the solid phase. Now we move on to the derivation part. If we are having n number of gas molecules, that is, there are n number of gas molecules which are getting adsorbed, and we have a set of s number of sites available for adsorption. So we could write the fraction of adsorption, that is theta, will be equal to n by s, where n is the number of gas molecule adsorbed and s is the total number of sites. In gas phase, the total adsorption can be expressed in terms of its partition coefficient. That is, there is a relation between the chemical potential and partition coefficient. So we have to write the partition coefficient for each of the phases. In gas phase, for a gas molecule, the partition function can be written as Qg is equal to Qg translational into Qg internal. But in solid state, we know that there will not be any translational motion. There is only internal motion. But during adsorption, we have to taken care of the adsorption energy also, along with the internal partition coefficient in the solid state. So Qs equal to Qs site into Qs internal into e raised to delta H by RT. Here the exponential function denotes the enthalpy of adsorption. Qs internal is the partition function associated by the internal movements in solid phase. The Qs site denotes the partition function associated with the site of adsorption. That is, it represents the partition function of the active site. So the total representation look like so. Again, we know that the free energy A in gas phase can be written with respect to the partition coefficient in gas phase as Ag is equal to minus kT ln Qg. If we are considering only one molecule, the free energy with respect to the number of molecules, that is, you know that dou A or dou G by dou N represents the chemical potential. So if we are considering only one molecule, this Ag will represent mu G. So we get mu G, that is chemical potential in gas phase. Now we move to the solid state. In solid state, that is for a molecule on the surface, we have to consider the probability factor. So the total probability in terms of partition coefficient and the number of gas molecule and number of active site, Qs total will be equal to Qs raised to n divided by n factorial into s factorial by s minus n factorial. So in the solid state, the free energy will be minus kT ln Qs total. So we have to put the probability factor for Qs total. So it will be look like so. Then here we have to apply the Stirling approximation. So what is Stirling approximation? It is log n factorial is equal to n log n minus n. So we have to apply this Stirling approximation in the above equation in order to find As, and from that we have to find mu s. So the equation reduces to As is equal to minus kT into n log Qs plus log s factorial minus log n factorial minus log s minus n factorial. Now we have to apply the Stirling's approximation. Now we get the expression as minus kt into n log qs plus s log s minus s minus n log n plus n minus of s minus n log s minus n minus s plus n. So we can cut the similar terms with opposite sign. ഞാൻ ബ്രാക്കറ്റ് ഇടാൻ മറന്നുപോയി. ഇനി നമുക്ക് സ്റ്റെർലിംഗ് അപ്രോക്സിമേഷൻ അപ്ലൈ ചെയ്യാം. സ്റ്റെർലിംഗ് അപ്രോക്സിമേഷൻ അപ്ലൈ ചെയ്തതിനു ശേഷം നമ്മൾ സിമിലർ ടേംസ് കട്ട് ചെയ്ത് കളയാണ്. എന്നിട്ട് ഫൈനൽ ഇക്വേഷൻ എന്താണെന്ന് നോക്കാം. സോ ആഫ്റ്റർ അപ്ലൈയിങ് സ്റ്റെർലിംഗ്സ് അപ്രോക്സിമേഷൻ ആൻഡ് simplifying the equation, we could get as equal to minus kt into n log qs plus s ln s plus n ln n minus s minus n into log s minus n. In the next step, we are taking the minus sign in the outside to the inside of the bracket. That is, we are multiplying the bracket parameters by minus 1. So we get as equal to kt into n log n plus s minus n log s minus n minus s log s minus n log qs. We know that free energy is dou as by dou n. So we have to differentiate the expression that we have obtained in the last step with respect to n. Now, during differentiation, the term s log s minus s will be reduced to 0. That is, it contains no term with respect to n. Then differential with respect to qs also becomes 0. So we get mu s equal to kt into n into 1 by n plus log n. അത് ഫസ്റ്റ് ടേം n log n ഡിഫറൻഷിയേറ്റ് ചെയ്യുമ്പോൾ കിട്ടുന്നതാണ്. n into 1 by n എന്ന് പറയുന്നത് എന്താണ്? log n ൻ്റെ ഡിഫറൻഷ്യൽ പ്ലസ് log n into n ൻ്റെ ഡിഫറൻഷ്യൽ 1 ആണ്. പ്ലസ് s മൈനസ് n into log of s മൈനസ് n ൻ്റെ ഡിഫറൻഷ്യൽ 1 by s മൈനസ് n മൈനസ് n ൻ്റെ ആണ് ഒരു മൈനസ് 1 മുകളിൽ വന്നിരിക്കുന്നത്. ഇനി പ്ലസ് log of s മൈനസ് n into s മൈനസ് n ൻ്റെ എന്താ വരിക? മൈനസ് 1. പ്രൊഡക്റ്റ് റൂൾ അപ്ലൈ ചെയ്തതാണ്. മൈനസ് എസ് ലോഗ് എസിൻ്റെ 0 ആണ്. ദെൻ മൈനസ് എൻ ലോഗ് ക്യു എസിൽ ലോഗ് ക്യു എസ് കോൺസ്റ്റൻ്റ് ആണ്, അതിൽ എന്നിൻ്റെ ടേം ഇല്ല, ഇൻറ്റു എന്നിൻ്റെ ഡിഫറൻഷ്യൽ 1 ആണ്. അതാണ് ഈ ടേം ഇക്വേഷൻ ഇങ്ങനെയായി മാറിയത്. ഇനി അതിൽ ഫസ്റ്റ് ടേം n ഇൻറ്റു 1 ബൈ n എന്നാൽ 1 ആവും. അതുപോലെ എസ് മൈനസ് n ഇൻറ്റു മൈനസ് 1 ബൈ എസ് മൈനസ് n എന്നാൽ മൈനസ് 1 ആണ്. അത് ക്യാൻസൽ ചെയ്ത് പോയി. അപ്പോൾ ഇക്വേഷൻ നമുക്ക് എങ്ങനെയായി മാറി? കെ ടി ഇൻറ്റു log n minus log s minus n minus log qs. അപ്പോൾ ഫൈനലി നമുക്കിതിനെ എങ്ങനെ മാറ്റി എഴുതാം? mu s equal to kt into log n by qs into s minus n. ഇനി നമ്മൾ ഇക്വിലിബ്രിയം കണ്ടീഷൻ അപ്ലൈ ചെയ്യാണ്. അറ്റ് ഇക്വിലിബ്രിയം mu g equal to mu s. mu g എന്താണ് കിട്ടിയത്? mu g is equal to minus kt ln qg എന്ന് കിട്ടിയിട്ടുണ്ട്. mu s നമുക്ക് kt ln n by qs into s minus n എന്ന് കിട്ടിയിട്ടുണ്ട്. സോ അറ്റ് ഇക്വിലിബ്രിയം minus kt ln qg is equal to kt ln n by qs into s minus n. In the next step, we are cancelling the kt term and we get log qg is equal to log qs into s minus n by n. മൈനസ് സൈൻ റൈറ്റ് സൈഡിലേക്ക് കൊടുത്തതാണ്. നൗ ലോഗിൻ്റെ ടേം കളഞ്ഞു കഴിഞ്ഞാൽ, അതായത് എക്സ്പൊണൻഷ്യൽ ഫംഗ്ഷൻ എടുത്തു കഴിഞ്ഞാൽ നമുക്ക് എന്ത് കിട്ടും? qg is equal to qs into s minus n by n. On rearranging this equation, we will get qg by qs equal to s minus n by n. This reduces to s by n minus 1. So s by n, what is s by n? We know that theta equal to n by s. So s by n will be 1 by theta. So the equation reduces to 1 by theta minus 1, and which is equal to 1 minus theta by theta. So taking the reciprocals, qs by qg equal to theta by 1 minus theta. qs qg എന്താണെന്ന് നമുക്ക് നേരത്തെ കിട്ടിയതാണ്. നമ്മൾ പാർട്ടീഷൻ കോഎഫിഷ്യൻ്റ് ടേംസിൽ ആദ്യം കണ്ടുപിടിച്ച് വെച്ചിരുന്നു. അപ്പോൾ ആ രണ്ടും ഇക്വേറ്റ് ചെയ്യുമ്പോൾ we will get theta by 1 minus theta is equal to QS site into QS internal into e raised to delta h by RT divided by QG translational into QG internal. But we know that QG translational is given by the expression 2 pi m kt by h square whole raised to 3 by 2 into V. By replacing V in terms of pressure, we will get QG translational is equal to 2 pi m kt by h square whole raised to 3 by 2 into kt by P. So we have to substitute this equation in place of QG translational in the above equation. So it looks like as in the board, theta by 1 minus theta is equal to QS site into QS internal into e raised to delta h by RT into P divided by QG internal into 2 pi m kt by h square whole raised to 3 by 2 into kt. So in the above expression, all the factors except P are all constant for a system under consideration. So we can reduce this equation as theta by 1 minus theta equal to k dash p. On rearranging this equation, we will get theta is equal to k dash p into 1 minus theta, which is equal to k dash p minus k dash p theta. Again rearranging, we will get theta is equal to k dash p divided by 1 plus k dash p. Now we have to replace theta in terms of x by m in order to arrive the expression for Langmuir adsorption isotherm. So we know that theta is proportional to x by m. So x by m equal to some constant k double dash into theta. Giving the expression for theta, we get x by m is equal to k double dash into k dash p by 1 plus k dash p, which is again a constant, that is k double dash into k dash is again a new constant k. The expression will be x by m equal to kp by 1 plus k dash p, and this is what is called, or what we get as x by m is equal to ap by 1 plus bp, where a and b are constant, empirical constant known as Langmuir parameters, and this is the Langmuir adsorption isotherm.